Today we're going to talk about quadratic inequalities. And there's two really types of quadratic inequalities that we're going to talk about. First, we're going to talk about when we graph a quadratic inequality. And graphing a quadratic inequality is just the same as when we're graphing a line. Just we graph the quadratic. Okay, you graph your boundary graph. And it depends on this sign right here. Okay, if you have the not equal to, it's a dashed line. If you have the equal to, it's a solid line. And then you shade above for the greater than, below for the less than. Okay, and always remember you can always test a point. And a good test, as long as the point isn't on the graph, you can always test the point 0, 0 to see if it makes the inequality true or false. Because what you're doing when you're shading is you're giving me all of the possible answers. That's what I don't think a lot of students, and really, when I taught it, I didn't realize that. Okay, so graph that inequality. Okay, that's in standard form. So I'm going to use our old school negative b over 2a. So I have a negative 6 over 2 times negative 3 halves. And I haven't done these notes ahead of time. So we're going to see how I do. So I get a positive 2 for my vertex. Okay, now I plug back in. So I have negative 3 over 2 times by a 2 squared plus a 6 times by a 2 minus a 4. So I have a negative 3. Oh, I need to erase here. Okay, so I have negative 3 halves times by a 4. Well, the 4 and the 2 cancel, so I get a negative 6 plus a 12 minus a 4. So a negative 6 plus a 12 minus a 4. That's going to be the point 2. So my vertex is 2, 2. 2, 2. All right, so 2, 2. It's a dashed line. Make sure you don't forget that. I always forget that. Okay, I open down because my a is negative. Remember that that's your y-intercept because x equals 0. So I have the point negative 4 on my y-axis. I now have a symmetry point that I can put down. And that's a dashed line. It's kind of hard to see. I might get maybe a little bit more dashy for you guys. Just make sure I can tell that it's dashed. Okay. And less than, I'm going to shade inside my parabola. Now let's test a point. Test 0, 0. Again, you can test any point as long as it's not on your graph. So I plug in 0 for y. I plug in 0 for x. So is 0 less than negative 4? No, that's false. So you're shading, not including that point. That's why you're shading all of this piece. Okay, so now this is in vertex form. My vertex in this case is 2, 3, opposite of what it seems there. So I go to 1, 2, up 3. Okay, here, open down. That tells me I open down, but I have a vertical stretch by 3. So I go left and right 1, but down 3. Left and right 2, but down 3 times 4 is 12. Ooh. So once I get 1 point, remember, I have a symmetry point. So I can just go over to my other symmetry side. Again, another dashed line. Okay, greater than is everything above. Again, let's test 0, 0. 0 is greater than negative 3 times by 0 minus 2 squared plus 3. 0. 0 is greater than negative 12 plus 3. 0 is greater than negative 9. That's true. So I did shade. My shading, I did a poor job shading, including that point. So I include all of that. Okay, quadratic inequalities, one variable. Okay, so when we have one variable. So I just want to highlight, now we're going to be solving where I'm like greater than 0 or less than 0. Versus what we were just doing is we were graphing where it was greater than 0 or less than 0. So these are on a grid versus I'm going to put these on a number line. Okay? And there's two ways to really solve these. Okay? One of them is by graphing and one of them is by using a number line. I'm going to show you both ways. I personally don't really care which way you use. I like number line. Actually, no. I like them both for different reasons. What you want to first do is get that. You're going to solve it as if it were equal to 0. And then try and factor. Okay, so I have minus 3 minus 1. Okay, so I have my 2 points. Remember what these are? So those are x-intercepts. Okay, I have an x-intercept of 1 and an x-intercept of 3. My graph opens up because A is positive. Oh, I need to erase that. I'm just going to do... Where's my undo? There's my undo. I don't really care what my graph looks like. I just care what my 2 x-intercepts are. Okay, now I'm looking to see where is this graph less than 0. Well, 0 is right here. That's 0. Anything below is less than. Anything above is greater than. Okay, so where's my graph? Since I'm looking less than 0, where am I less than 0? I'm less than 0 from 1 to 3. Okay, and your answer is going to be an inequality. So that's how you would solve it if you like this graphing method, where you just get a quick sketch and then you figure out where am I above the x-axis or below the x-axis. Now solving this by using algebra. Okay, so similar steps. Write it as an equation. Get one side to 0. Okay, I could have at this point, I could have also, I guess now thinking about this, I should have done this. So write it like that. Get one side to be 0 with your inequality symbol. I apologize. Ignore this work. Get one side to be 0 with your inequality symbol. Then set it equal to 0. Actually, no, I'm not going to set it equal to 0 yet. Now factor. So I get those factors, and I have a -7 and a -3. Now put those numbers on a number line. So set those factors equal to 0. So x minus 7 equals 0, and x minus 3 equals 0. Notice how I didn't put an inequality symbol. So I get 7 and 3. I'm setting them, and I'm getting that, okay, 3, 7. I'm getting them on a number line. Now plug in a point. Okay, we're going to test a point. We're going to test a point where a number is less than 3. I'm going to test x equals 0. So test x equals 0 and that. So if I plug in 0, I get a -7 times by -3. Is that less than 0? False. So that's not part of my solution. Now test a number in between. I'm going to test x equals 4. I just like testing smaller numbers. So I test 4 minus 7. That is a 3. And that's a -3. 4 minus 3, that's a 1. Is that less than 0? That's true. So this is part of my answer. Now, I'm going to test a number that is greater than 7. So I'm going to test 8. 8 minus 7 is 1. That's by... It is a 8 minus 7. No, that's a positive 1. And then 8 minus 3. That's a positive 5. I don't know what I'm thinking. That's a 5 less than 0. No, that's false. So that's not part of my answer. Your answer is wherever you're true. So I am true from 3 to 7. And I have one little mistake in there. I put equal to signs. They're technically not equal to because, this right here is not equal to. Okay, and that is your video on quadratic inequalities.